Hi everybody, today I'm going to do a AP Computer Science review video on the AP Unit 10 Recursion. This is a review video, so it's going to go pretty quickly. This is a pretty quick topic, and I'll go over all the specific details as it relates to that specifics of the AP curriculum. Alright, so let's take a look at the concept of recursion here, and as it's defined by the AP curriculum. Alright, so it defines this as the recursion method or the recursive problem as it relates to both math and computer science. So you'll see how recursion works and how the idea of a recursive method, of a method calling itself, is part of this. So we have covered all this content before. Recursion is a unit in the Computer Science 40S course. It's actually the first new unit. It's just a little unit, and so this is not a big topic. Recursion is one of those things that you kind of can get it very quickly, or sometimes it takes a little while to really grasp what's going on. All right, so let's take a look at how it relates to the AP curriculum. So Unit 10 recursion has two specific learning outcomes. What is recursion and what is recursive searching and sorting? In terms of big ideas, it falls under the idea of control. All right, in terms of the AP weighting for recursion, recursion falls between 5 and 7.5%. So basically like Unit 2 or Unit 5. It's a little bit less than inheritance, a little bit less than arrays, certainly less than looping, iteration, but it's definitely part of it. It's part of it. And you can expect a recursion type question, probably in either the multiple choice or the free response, or both, right? All right, so let's dive into the idea of topic 10.1, recursion. All right, so here you can see the specific AP learning outcomes for this topic. You can pause this video or go to some of the resources to read it more detailed. But when I taught the word recursion, I said, well, recursion is based on the idea of recurring, of a function defining itself or a method that calls itself. It can be a tricky concept. So when I did this, I did some in-class examples of a word, looking up a word in a dictionary, which might require you to look up another word, which might require you to look up another word, and then you come back to the word you were looking up originally, okay? I did that in pseudocode. I did it with examples of looking up a word would require you to look up another word. So it could be pseudo-coded as a method that calls itself. All right, we got into more detail of dividing this up and how this is about methods and how methods call methods, okay? By doing the math idea, this is a very traditional way to teach recursion using the math factorial, right? Where you can see that this could be written with a loop, the factorial solution, but that factorials themselves are math functions that define themselves. So in this, we created a recursive method to calculate factorials, and I talked about the different cases that recursive methods have. They have what's called the base case. The base case is what stops recursion. And then you have the recursive case, which is where the method calls itself. So if we see this applied to the factorial function, right, you can see that factorials can be defined in terms of themselves, right? All right, so moving this forward, the recursive factorial function you can see here, that it passes a value, and then there's a base case, two base cases actually, where I return 0, I return 1, or the factorial case, where the method calls itself, okay? The positives of recursion, or what makes recursion good, is often shorter, more cleaner looking code, easier to read. The negatives of recursion is that it actually could end up causing more memory to be used by all the different method calls that are taking place. Recursion is a tool in your programming toolbox. It does become a more practical tool in more higher level data structures that the AP curriculum doesn't really cover. But recursion is a good thing to know moving forward in your studies of computer science. Now that was a real crash course in recursion. I would absolutely encourage you, if you're struggling with recursion, to look back at my resources of my 40S course, where you can see much more detailed videos about recursion. You can see a much more laid out example with comments and really well laid out sort of method of seeing how recursion takes place. All right, but let's move on to topic 10.2 of the AP Computer Science curriculum, recursive searching and sorting. So this is, again, covered in the AP curriculum, but very briefly, right? It talks about something called the binary search algorithm, which can be done recursively. It also talks about the linear search algorithm, okay, and how the binary search is more efficient. But what it doesn't say is how to implement that algorithm. It's not something you need to know for that. It also talks about the merge sort algorithm, which can be done recursively. Now, ironically, it doesn't cover something like the quick sort algorithm, which is also done recursively. But nonetheless, that's what the AP curriculum says, so that's what we should kind of look at. Let's look at the binary search from a theoretical standpoint. It's a divide and conquer algorithm. The binary search only works if you have a sorted list. So once a list is sorted, you can use the binary search by continually examining the middle item in a list. All right, so let's sort of see this animated out. Let's say I'm searching for the number 12 in this list or array, whichever way you want to look at it, of items. So I start in the very middle of the list, and I'm looking for 12. Well, 9 is not 12. However, 12 is greater than 9, which means I don't need to search the back half of this list, or the front half. I don't need to look at the 1, the 5, and the 8, because I know that 12 is greater than 9. So what I can do is just look at this section of the list. Divide it in half again and say, is 20 12? No. But again, I can cut the list in half and just search under this section. Is that 12? Yes, it is. I just found the item I was looking for. So the binary search is incredibly efficient because each time it iterates, or it calls itself, it divides the amount of things you're looking through, in half. So it's incredibly efficient, right? So here you can see some statistics. In an array of 100 elements, no more than 8 checks would need to be done to find the item. In an array or a list of 1,000,000 items, no more than 20 checks. Now compare that to the linear search. Worst case scenario would be 1,000,000 checks. 20 is certainly less than 1,000,000. All right, so here you can see an implementation of the binary search algorithm using an array and using a loop. But I also could show you a version of the binary search algorithm that uses recursion. And here you can see that here, where I use a wrapper method to hide the fact that it's being done recursively, where I pass it an array and I recursively search by just adjusting the midpoint of where I'm searching from, going down by 1, going up by 1. But again, the AP curriculum doesn't actually require you to write this algorithm. You can see it here, okay, but it's not actually required of you. Now, it also talks about the selection sort and the merge sort. So you can look at various versions of this in some of the extra content of both my 40S course and my AP course and even my IB course if you want to look at that. But let's summarize this unit on recursion. All right, so here's what it says. So now, having studied this and having seen how we laid it out at the beginning, we covered the concept of recursion and searching and sorting and how recursion could be part of this. Let's look at a sample exam question. So in this, we have a method called Mystery 1 and a method called Mystery 2. Now, Mystery 1 is a recursive method because you can see within Mystery 1, it calls itself. Mystery 2 is not a recursive method. It is an iterative or a looping method because there you can see a loop, a while loop in there. So let's dig a little deeper. Method Mystery 1 takes a parameter, the integer n, and if n is 1 or less, it returns 1. That's our base case. And if it's greater than 1, it adds 5 to it and makes a recursive call to that number minus 1. The method Mystery 2 takes also integer n as a parameter, but what it does is it creates a total variable set to 0, an x variable set to 1, and then loops while s is less than n. Inside the loop, it adds 5 to the total, and it adds 1 to x through every iteration. And then at the very end, it returns the total. So if we, for example, used 5 as the initial argument, when Mystery 1 is called initially, it would call 5 plus Mystery 1 of 4, because it's n minus 1. Then it would recursively call it again, 5 plus Mystery 1 of 3, and then 5 plus Mystery 1 of 2, and then 5 plus Mystery 1 of 1, which would hit our base case. So when it called it the fourth time, it would hit our base case, and 5 plus 1 would be 6. So that would return to call 3. So now we're adding 5 plus 6, which is 11, returning that to call 2. So now it's 5 plus 11, 16, returning back to call 1. So now it's 5 plus 16, so it would return 21 from mystery 1 if we called it with the value 5. Now let's examine how mystery 2 would work. So because it's using a loop, total would start at 5, x would start at 2 because it was 0 and 1, and I added 5 and I added 1. Then it would go to total equals 10, x equals 3, total equals 15, x equals 4, total equals 20, x equals 5, which would cause the loop to end because 5 is not less than 5, and it would return 20. So we have two different return values, 20 from mystery 2 and 21 from mystery 1. The question asks, how could we intend them to return the same value? And we're given options A through E. Well, since it's off by 1, the easy fix would be in mystery 2 if we set total to 1 right off the bat, and we would keep adding 5, then it would also in the end return 21. So the correct answer in this case is A. A is the correct answer for this. All right, that was a very fast video on recursion. Let's just take a quick look at a little bit more about that in terms of you could potentially go and look at my website, because if you felt that went too quickly, what I would encourage you to do is go to the 40S sections and resources and watch more recursion type videos to really grasp what's going on there. But that's it. That's my quick AP recursion review video. Like and follow and watch for more review videos of the AP Computer Science curriculum.